Hello my dear students of class 12th. Today I am here to just tell you about a very important topic of this unit. The name of topic is dielectric. So listen here. Dielectrics are what? Its second name is insulator. It is just like insulator. Insulator. Only difference is what? First of all I am telling you similarity. Dielectric or insulator. Both are such type of materials which do not allow electricity pass through it. Okay. But if it is dielectric, then dielectric will exhibit electric field. Insulator does not. Remember that. All the insulators are not dielectrics. All the insulators are not dielectrics. So there is a important property of dielectric. Dielectrics are such type of materials which do not allow electricity or charge flow within it but shows electric field. This is called dielectric. Now dielectric is of two types. The first type is called polar dielectric and second type is called non-polar dielectric. Polar dielectric example like HCl, H2O, etc. Non-polar dielectrics example oxygen, carbon dioxide, etc. Okay. Now question is, what is polar dielectric and what is non-polar dielectric? So first of all, I am going to make you understand about the polar dielectric. Look here. Polar dielectric here. Just try to understand. This is HCl, which is the example of polar dielectric. Now question is, why it is polar dielectric? You can see H is here positive charge, Cl is here negative charge. Both positive and negative charge are separated at a certain distance from each other. Now positive charge or negative charge means electron and proton both possess same magnitude but different nature, opposite nature. You all know that if opposite nature and same magnitude charges are separated at some distance, they form electric dipole. So here you can see electric dipole is present. So what is polar molecules or polar dielectrics? Such type of molecules, such type of dielectrics in which center of mass of positive charge and negative charge do not coincide, because if they coincide there will be no separation. So positive charge center of mass is different and negative charge center of mass is different. They are separated at some distance. So such type of molecule, such type of substance, such type of dielectrics are called polar dielectrics. So this is the example of polar dielectric. Now here is plus, here is minus. You can see this is the direction of electric dipole moment. Now I have considered a sample which consists of polar molecules. Means here is only one molecule, here 1, 2, 3, 4, 5, 6, 7, several molecules are present. So I have considered a sample of polar molecule. Because each molecule shows its own electric dipole. So here one dipole, second, third, fourth, fifth, sixth, seventh, eighth, because 8 molecules I have considered in the sample. So there are 8 electric dipoles you can see in this particular sample. Important thing is what? There is no fixed direction of each electric dipole. Each electric dipole randomly distributed. So if we take total electric dipole of this sample, it will become 0. Why 0? Because electric dipole is vector quantity. So when you will add all the dipoles, individual molecules dipole, you will get net dipole 0. So what the important thing you are getting here? Important thing is what? In the absence of external electric field, in the sample, individual electric dipole moments are present, but the net electric dipole is 0. Okay, this is for polar molecule. Now look here. Bring this polar molecule sample in the external electric field. Here what you observe? Individual dipole moments are present, but the net dipole moment is 0. When you bring this particular sample here, now this is positive and this is negative, because dipole's direction is always from minus to plus, like this. This is one molecule. When you are bringing this sample here, sample was in this way, this dipole was in this way, then what happened? External electric field positive is this side, negative is this side. This is dipole's positive, this is dipole's negative. So what happens? A torque will produce. Due to that torque, it will come in this way. Means dipole direction will be as it is as the direction of external electric field. You can see this is arrow direction, this is plus, this is minus. Now plus is towards minus and minus is towards plus of external electric field. That is, all the dipoles align itself in the direction of external electric field. So inside this sample you will observe there is an induced electric field present. Induced, whose direction is this, because inside positive is here and negative is here. So this is direction of induced electric field. This is direction of dipole. This is direction of induced electric field. So the net electric field will be external electric field minus induced electric field. Now look here. You can understand here if this was dielectric. Now you can see there is no motion of charge or motion of electricity in this particular sample, but electric field is present. That is why it is dielectric. And because here individual dipoles are present in each molecule, that is why it is polar molecule. Polar molecule is what? In which center of mass of positive charge and center of mass of negative charge do not coincide. Okay. Now number 2 is non-polar dielectrics. Now look here. In the non-polar dielectrics, I have taken the example of carbon dioxide, that is CO2. So just try to understand why it is non-polar. This is oxygen, this is oxygen, this is carbon. Arranged in this way. Means this is the center of mass of this negative charge. This is the center of mass of this negative charge. Now for this negative charge and for this negative charge, there is a combined center of mass which is here. And already here positive charge center of mass is present. Means here two center of mass is present. Negative charge center of mass as well as positive charge center of mass. What you are observing? You are observing here that in the case of non-polar dielectrics, center of mass of negative charge as well as center of charge of positive charge coincides with each other. That means there is no dipole formation. Understand? In the polar molecule, dipole formation was there, but in non-polar molecule there is no dipole formation because here negative charge center of mass and positive charge center of mass coincide with each other. Understand? Now, so this is a type of figure in which I was trying to show this is the center of mass of positive and same center of mass for negative, both coincide. Now, I have taken a sample of non-polar molecule. Now this is a sample in which 1, 2, 3, 4, 5, 6 molecules of non-polar dielectrics are present. This is center of mass coincide positive negative. This is second one, third one, fourth one, fifth one, sixth one. Means no dipole is present individually, hence net dipole also here 0. In the polar molecule there was individual dipoles present, but all the dipoles randomly distributed, due to that net dipole was 0. And here already there is no individual dipole, hence net dipole will be 0. Means either the case of polar molecule or the case of non-polar molecule, in both the cases, in the absence of electric field, net dipole is 0. But in polar molecule, individual dipoles are present, but in non-polar molecule, no individual dipoles. Okay. Now bring this sample in the external electric field here. And what happened? This is positive direction of the field and this is negative direction of the field. This is external electric field. You can see the arrow sign, E external. The moment when you bring the sample here, then what happened? Both the center of mass are coincide here. When you bring here, positive will try to move towards the negative field and negative charge will try to move towards the positive side of the field. Due to that, there is a separation created between the center of mass, you can see. And because there is a separation created, means now each molecule starts to produce electric dipole. And the direction of electric dipole is same in the direction of external electric field. Hence, the induced electric field which will produce here, that will be opposite to external. Due to that, net electric field will be the external electric field minus induced electric field. In this way, you find that either the dielectric is polar or the dielectric is non-polar. In both the cases, net electric field is the difference of external electric field and induced electric field. Now, question is, what is the role of dielectric in the case of capacitor? My dear students, this is parallel plate capacitor. In this parallel plate capacitor, if you introduce any dielectric, either it is polar or it is non-polar, then what it helps? It increases the capacitance. By introducing the dielectrics in between the metal plates of the capacitor, we can increase the capacitance. Question is, how we can increase? You all know that C equals to A epsilon naught upon D. This is the formula of capacitance when only air is present. And this can be written as C equals to K A epsilon naught upon D when any dielectric is present there. Let for air you are showing it by C naught, or for any medium you are showing it by Cm. This is dielectric medium is present. Here is D, here is D, A epsilon naught both are present here. So by calculating these two, you can understand how the capacitance will increase. So in my next lecture, I will tell you by introducing this dielectric, how the capacitance will increase with the help of a derivation. Till then, you will try to understand all these concepts of dielectrics, polar and non-polar molecule. Next video, I will make you clear how the capacitance will increase. Okay, all the best. God bless you.